What is going on, guys? Today we're at the Mathematics and Science Academy of UTRGV here in Edinburgh, and we're here to find out, do high school students know what the polarization of light is? Are you guys ready? Let's go.
When I was talking about me,
So, what is your name?
Matthew.
Maki. What grade are you in, Maki?
I'm a senior.
You're a senior at the Mathematics and Science
Yes,
Academy.
sir.
Do you know what the polarization of light is?
primary, secondary, tertiary.
No.
Just give me anything.
Polarization
What do you
of
know as
light.
the polarization of light?
The reflection of light.
The reflection of light.
That's it. Thank you.
Thank you.
What is your name, sir?
Isaac Juarez,
Isaac. What grade are you in, Isaac?
11.
11. Do you know what the polarization of light is?
Negative 3.46.
Oh my god. Okay. But what is it? Like, give me the concept. What is it?
Polarization of light. It's when light gets attracted to something else.
What is your name?
Misael.
Misael, what is your name?
Yam little, sorry.
Guys, what grade are you guys in? 12?
I'm a senior.
12. Seniors in high school?
Yes, sir.
Do you guys know what the polarization of light is?
Polarization of light?
Give me anything. What's in your head about the polarization of light?
Polarization. I don't know. Is that like it doesn't work?
That's not what polarization means.
I already forgot what polarization means. It doesn't mean like
There's a hint right here.
Ray-Bans?
They're polarized Ray-Bans.
We're here to ask you a very important question. Do you guys know what the polarization of light is?
No.
Give me anything. What is in your mind about the polarization of light? What's the idea that you have in your mind? Glasses. I don't know. What happens to light when it gets polarized? Hi, sir. What is your name?
Everardo Olivares.
Everardo. What grade are you in, Everardo?
I'm in 12th grade.
12th grade. We have one very important question. Do you know what the polarization of light is?
I actually don't know. Can you inform me?
Give me what's in your head. What's in your mind about the polarization of light? What do you have as the idea of the polarization?
The light spectrum. Is there anything?
That's it.
Polar coordinates. So like y equals r sine theta.
Hiya, it's Carlos.
Carlos, do you know what the polarization of light is?
I think I do.
What do you have?
Alright, so when light leaves, I don't know, like a light, it's coming down and the photons are bouncing in all different directions, right? But the instant you put, I don't know, a lens, all the photons, as soon as they go through it, they orientate themselves and they magnify it in a way. And that's what I think the polarization of light is.
Good job.
Thank you.
Okay, so it is clear that most high school students do not know what the polarization of light is. With this being such a crucial topic in physics and the world in general, let's find out what it is. Let's go! So to understand the polarization of light, first we must understand what light is. And light is basically a type of electromagnetic radiation that belongs to the electromagnetic spectrum, which ranges from radio waves to microwaves to infrared, visible light, ultraviolet, X-rays, and finally gamma rays, each with an increasing frequency of wavelength. A light wave is an electromagnetic wave that travels through the vacuum of outer space. Light waves are produced by vibrating electric charges. The electric and magnetic vibrations of an electromagnetic wave occur in numerous planes. So now that we know about light waves and the electromagnetic spectrum, we know that there are two forms of light, unpolarized and polarized. And unpolarized light refers to a light wave that is vibrating in more than one plane. It is possible to transform unpolarized light into polarized light. Polarized light waves are light waves in which the vibrations occur in a single plane, whether it's horizontal or vertical or anything in between. The process of transforming unpolarized light into polarized light is known as polarization, and there are four methods of polarizing light, which are polarization by transmission, polarization by reflection, polarization by refraction, and polarization by scattering. So here we have an example of polarization by transmission with the use of a vertical polarizer. And polarization by transmission basically means utilizing a Polaroid filter. Polaroid filters are made of special material that is capable of blocking one of the two planes of vibration of an electromagnetic wave. A Polaroid serves as a device that filters out one half of the vibrations upon transmission of the light through the filter. When unpolarized light is transmitted through a Polaroid filter, it emerges with one half the intensity and with vibrations in a single plane. It also emerges as what is known as polarized light. Here we can see a different view of the example that was just shown, where we have the Polaroid filter and the unpolarized light waves going in the vertical and horizontal directions. And after passing through the vertical polarization filter, we have the polarized light going only in the vertical direction. Unpolarized light can also undergo polarization by reflection off of nonmetallic surfaces. This is known as polarization by reflection. The extent to which the polarization occurs is dependent upon the angle at which the light approaches the surface and upon the material that the surface is made of. The reflection law also states that the angle of incidence, which is the angle at which the light comes in, is equal to the angle of reflection. Polarization can also occur by the refraction of light. This is known as polarization by refraction. Refraction occurs when a beam of light passes from one material into another material. Both refracted light beams are polarized, one in a direction parallel to the surface and the other in a direction perpendicular to the surface. Lastly, polarization by scattering transpires when light strikes the atoms of a material. It will often set the electrons of those atoms into vibration. The vibrating electrons then produce their own electromagnetic wave that is radiated outward in all directions. This newly generated wave strikes neighboring atoms, forcing their electrons into vibration at the same original frequency. These vibrating electrons produce another electromagnetic wave that is once more radiated outward in all directions. This absorption and re-emission of light waves causes the light to be scattered about the medium.
Okay, so now that we know what the polarization of light is, it is our duty to inform the students about the polarization of light. Okay, so this is Maki. We interviewed him last time. He's in 12th grade, and he did not know what the polarization of light was, so we're going to be explaining it to him. What's up, Maki? What's up? Okay, so you know how light can be either a particle or a wave? Okay, basically, a light wave is produced by the vibration of the light particles, and unpolarized light is basically when the vibrations of the particles are in multiple directions. Like it could be horizontal, vertical, or anything in between. And once it passes through a polarization filter, like sunglasses or 3D glasses or magnifying glass, anything, it'll go in one direction only. Like imagine the filter and it's like a slit, and before it passes through, it's vibrating in multiple directions. It passes through the slit and it's vibrating only in vertical directions. So for example, 3D glasses, they have one lens that's parallel horizontally and another one that's parallel vertically. So that allows you to see 3D movies like it's coming at you because it's polarizing light, so that only a certain wavelength or frequency goes through. Yeah, so that's pretty much it. That's the polarization of light. Okay, so we're back here again with Gabby. She's in 12th grade, and we're going to be explaining what the polarization of light is. So, you don't know what it is, right?
No, I don't.
Okay, so basically the polarization of light is basically So this is Sophie. She's in 12th grade. We interviewed her last time. She had no idea what the polarization of light was, so we're going to be explaining it to her. Okay, so the polarization of light. Basically, light is a wave and a particle, right? This is Ever. He's in 12th grade, and last time we explained, well, we asked him what the polarization of light was, and now we're going to be explaining it to him. So, basically, Ever, you know how light travels in a wave, and it's also a particle? And that allows you to see the movie in 3D. Just a real life example of polarization.
Just in time for the ringer too.
Yeah, that's true. Thank you for listening to our lesson on the polarization of light. I hope that you learned something from this and that you enjoyed our presentation. And I'll see you next time at Physics at MSA.